The following video was recorded before the merger of Reliam, Stratalux, and G2 into one company. We are now Mission. Let's achieve yours.
All right, hello everyone, and welcome to our fourth webinar in the series on the Well-Architected Framework. Excited to be here with you today. Today we're going to talk about the cost optimization pillar, which is the fourth pillar, as I said, in the Well-Architected Framework. So let's start off and do a little introduction. My name is Jonathan LaCour. I'm the Chief Technology Officer at Reliam. I'm a technologist, I'm a programmer and a cloud strategist, and I've been using cloud since the very early days of cloud, and I'm excited to be here today to talk to you about Well-Architected. Let's talk a little bit about who Reliam is, and actually you'll see multiple logos up there, Reliam, Stratalux, and G2 Tech Group. We are a recently merged together three businesses into one kind of powerhouse. We are an advanced consulting partner and managed services provider built on top of AWS. And we help customers optimize their workloads, and we can actually manage workloads for customers on top of AWS. And we have over 80 certifications across multiple kind of large groups of technical resources. And so we have a broad and deep amount of experience with AWS. So in order to kind of make sure we're all paying attention and engaged today, we're going to ask some questions as we go throughout. Quick note, all of these questions are totally anonymous with your answers, so you can answer with confidence. So I'm going to go ahead and let Joshua, my co-organizer here, toss up the first question, which is about how your company is currently using AWS. So I get to watch the answers as they're rolling in. So go ahead and let us know a little bit about the audience here, how experienced you are with AWS. All right, Joshua, I'm not seeing any answers flow in yet. Here they come, maybe? Okay, here we go, good, excellent. All right, let's go ahead and see what we got. Oh, wow, looks like over half of you are already using AWS for your production environment, and that's pretty exciting. A good percentage of you are using AWS for test and experimental purposes or doing hybrid approaches. A very small percentage of you are in the process of migrating to AWS, and that's great to hear. Okay, awesome. Sounds like we have a crowd of people who have some experience using AWS. So let's talk a little bit about our agenda for today's webinar. So first, I'm going to give you an introduction to Well-Architected. If you've attended some of the prior presentations, some of this will be a rehash, but we have updated new metrics on kind of what we've discovered by delivering Well-Architected reviews to customers. And then we're going to go into the design principles. So every pillar has design principles and area of focus. We'll talk about the general design principles for cost-optimized workloads in AWS, and then we'll talk about the areas of focus, which are cost-effective resources, matching supply with demand, expenditure awareness, and optimizing over time. We'll also have some time for Q&A. As you're going through today, if you have questions that pop in your mind, go ahead and enter them in the questions interface for the webinar. We have a senior platform engineer on with us, Brian, who will try to answer some of the questions as we go. And then at the end, I'll kind of look at the questions area and try to answer any questions that were particularly interesting or kind of as time permits. Also note that in the GoToWebinar section, there's actually a handout section that you can look at a couple of different kind of downloadable PDFs to kind of peruse a little bit about Reliam and some of our offers. So let's get started. The Well-Architected Framework. So back in 2015 at AWS's annual reInvent conference, AWS's CTO Werner Vogels announced the Well-Architected Framework, and it was a series of 5 white papers that targeted 5 separate pillars of best practices and guidance for building your workloads for the cloud and taking full advantage of AWS. And altogether, the framework helps ensure that your applications are architected properly. And they've continued to evolve the Well-Architected Framework over the years. And now it's, I believe, the most complete and thorough collection of best practices and guidance that is available for people who are looking to make the leap to AWS or who are already there. So what are some of the benefits? Well, first, the principles help you move more quickly, right? In my experience, this is the biggest demand on operations teams and in product organizations. If you're a product team delivering kind of features to end customers, the most important thing is how quickly can we get those features in the hands of our customers? And the well-architected framework gives you a lot of best practices that ensure that you can do that. You can deliver quickly. It also helps you surface risk and mitigate those risks before you make some decisions. And that's a really critical aspect as well. Agility and moving quickly is important, but you also want to do so in such a way that you're balancing your risk. And as a CTO, I have to make a lot of big, expensive decisions, as I'm sure many of you do in the room. And the well-architected framework helps me make informed decisions, and it can do the same for you. You can kind of benchmark against the best practices of AWS, and that's really, really helpful. So let's dive in to a little bit about what we've learned from performing well-architected reviews. So in the past, only Amazon could perform well-architected reviews with their solutions architects, but now partners like Reliam are actually able to deliver well-architected reviews for our customers. And this has been a huge success for us and for our customers. And over the last few years, since we were a launch partner for this program at reInvent last year, we have performed dozens of well-architected reviews. And this is some updated, as of today, data about what we've learned by performing well-architected reviews. And you can see that across all 5 pillars, we have found high critical issues across all of the reviews that we've done. 96% of the time we find something in the security pillar that we really need to help address. And for today's cost optimization, it's almost half of the well-architected reviews we surface critical cost optimization issues. So it's a really valuable exercise. And the great thing about the program is AWS essentially sponsors it along with a partner like Reliam. So we can actually deliver these reviews for free, and AWS will subsidize in the form of a $5,000 service credit, and you get 20 hours of remediation from our kind of certified engineering team to help address any of the issues we surface, because we almost certainly will surface some issues. So that's a little bit about well-architected and how AWS is really pushing for their customers to be well-architected. So let's dive into the cost optimization pillar, starting with the design principles. So the 5 key design principles for the cost optimization pillar are to adopt a consumption model, to measure overall efficiency, to stop spending money on data center operations, to analyze and attribute expenditure, to use managed services to reduce cost of ownership. So let's talk about each of these in depth. So the first is to adopt a consumption model. And first of all, what do we mean by consumption model? So if you think back to 2006 when AWS launched S3 and EC2, one of the really pioneering concepts that came along with those cloud services, those first cloud services, was utility billing. So the ability to pay only for what you use. So the ability to spin up a virtual machine for 3 hours, pay for those 3 hours, and then shut it down again. And prior to that, businesses generally consumed infrastructure in a very capital-intensive way, right? By purchasing hardware and then paying to host, operate, and manage it. And even though cloud was introduced now well over 10 years ago, many businesses are not fully adopting the consumption model. And that doesn't just mean using cloud, that means using it in a way that takes full advantage of that consumption model. So a common thing that I see is organizations will say, we're going to go all in on AWS, and then they'll just take their physical servers, map them to virtual machines in AWS, and essentially perform a lift and shift operation. And you're not really getting the full advantage of what AWS has to offer. So part of this design principle is really to align your spend with the business requirements, scale up and down as needed based upon usage and demand, and pick the right resource types for your use case. And we'll unpack this design principle in the focus areas in a little bit. So let's ask another question real quick to ask if your organization, if you believe you fully adopted the cloud consumption model. Now, given that only half of you are actually fully in production on AWS, I would expect there to be a little bit of a divergence here, but we'll see. Give everyone a few minutes to kind of respond here. And this is really interesting. When I phrase this to CFOs, frequently talk about the consumption model, it's a big hurdle for a lot of CFOs to understand because especially in kind of companies, CFOs who have an IT background, they're very used to the on-prem kind of model. So going through this transition can be difficult kind of across multiple parts of the organization. All right, let's see how the poll came out. All right, so no, 70% of you have not yet. And I'm actually not too surprised by this result. As I mentioned, we've done dozens of well-architected reviews, and what we find is that's generally true. People haven't fully embraced, right? They've gone kind of halfway down the path or even less. So it's good that you're all here today to learn a little bit about how to do that. So let's talk about the next design principle, and that is to measure overall efficiency. So don't just focus on costs. For most organizations, the only consideration that is made is how, especially when in a cost optimization kind of exercise, what's the cost? What are my hard costs? And it's also important to look at kind of the business output of every system, right? So if you look at a holistic view of all your infrastructure that you're kind of consuming on AWS, it's important to note that it's not just the hard cost of a particular system, it's also the business output of that system. You might be able to tolerate a higher cost if you have a much higher business output. So you really have to have the full picture, right? The overall system efficiency drives better decision making. So that's the second design principle here. The third should come as no surprise. AWS really believes that you should stop spending money on data center operations. Again, they're a vendor who is there to encourage you to move to their product, to the cloud. But as we've helped customers, make that move over time, we've been around for 17 years, providing management of infrastructure on-prem and now in the cloud. And we're 100% focused on AWS at this point. And that's because we actually believe that this is good advice, right? What is your business's core area of expertise? If it's not data center operations, right? Or even if you think it is, can you really be as proficient at data center operations as AWS can at kind of hyperscale, cloud scale? Their advice is really just leave it to AWS so you can focus on delivering value to customers. And I think generally speaking, that can be very good advice. Unless you have extremely large scale, it's very difficult for you to do as good a job as AWS is going to do on data center operations. So that's the third design principle. So let's ask real quick, what percentage of your infrastructure is in the cloud? So earlier I asked if, what you're currently using it for, but think holistically about all of the infrastructure spend you have. What percentage of your infrastructure and systems are up in the cloud? I doubt we'll get anybody with 100%. We might, you never know. But I put a couple bands there for you to answer. See some answers rolling in. That's great. All right, I'm actually quite curious about this. All right, let's see what we got. Oh, very interesting. Okay, so the kind of almost the majority is under. Oh yeah, the majority is under 50%, which is very interesting. As a kind of consulting partner with AWS, we spend a lot of time moving people's workloads up into AWS, and our experience is that most companies still have a significant amount of on-prem infrastructure that they're really wanting to make the move on. So that's what we do. We're here to help with that. So be aware of that kind of opportunity with partners like Reliam. Okay, let's go to the next design principle here. And that is to analyze and attribute expenditure. So if you are on-prem, and it sounds like many of you have a lot of your infrastructure still on-premise, data center tracking expenditure can be really, really hard. Applications are deployed to fixed size hardware, and you have to allocate costs for things like power, cooling, management of the servers, and you've got some significant capital expenditures on that hardware that you have to figure out, how to divvy that up and how to balance it and distribute it over the useful lifetime of the hardware, right? How long is the useful lifetime of hardware? So this is all quite difficult, but in the cloud, you actually get the ability to be a lot more granular. And by breaking down costs into very, well-defined areas for things like product teams or business owners or specific features even, right? You can enable your business to really optimize and reduce cost, to understand I'm spending this much on this system that has X business output, and that really might not be worth it, or maybe I need to really focus on my optimization there. So that's a really, really great design principle. This is really kind of the heart of the matter. The next design principle is one near and dear to my heart, which is to use managed services to reduce TCO. And that means that you shouldn't just leave data center operations behind. You should try to leave behind as much systems management as possible, right? So managed services means two things in the context of this design principle. So the first thing it means is the services that AWS provides that are fully managed. So that's things like RDS, right? RDS is a service where you can get access to a MySQL, Postgres, Oracle database, and it's as fully as a service. So there's no server for you to manage, no software license for you to worry about. You literally pay as you consume it, right? And that is a huge burden relieved from your team. And because AWS operates these managed services at cloud scale, that means that they can really drive costs down. They can, negotiate better licensing. They can create lots of efficiencies, and kind of on a per transaction basis, on a per minute, hour, whatever basis. You can see that there's actually cost benefit to using the managed services. The other thing that we mean by managed services here is from managed service providers like Reliam. So there are aspects of your systems that still require servers and management of those servers, infrastructure that is lower level than these managed services. And companies like Reliam, that's what we do. We provide that as a service to our customers. So if you don't want to manage servers anymore, you don't want to deal with the maintenance, the operating system patching, the 24/7 monitoring, you can take advantage of a company like Reliam and say, hey, take care of that. We're going to focus on creating value for our customers. That's not our core competency. So that's another kind of key design principle here for cost optimization is, try to unburden yourself of as many things that are outside your core competency as possible, adopt managed services, and really drive value for your customers. So those were the design principles, the 5 design principles. And now we're going to dive into the focus areas. So each of these 4 focus areas goes in depth on a particular topic around cost optimization. So the first is cost-effective resources. So AWS provides dozens of services, right? And hundreds of features and configuration options and purchasing options as well for those services. And that means that it can be a little bit of a challenge to decide which resources you use, right? How do you make the right decisions to provide good performance, but also be cost optimized? And there's a bunch of different decisioning considerations. We're going to go through each of these. So we'll start with appropriate provisioning. And when it comes to appropriate provisioning, if you're a heavy user, you're likely familiar with the fact that many services have attributes and properties that you can configure. So things like, what's the size of the instance that is backing my RDS kind of instance? How many nodes are there in my EMR cluster, right? And there's a lot of these different attributes, and each of these can have an impact both on your performance and quality of service and on your cost. And these are the type of things that you really need to adopt a very cloud native model for, right? You don't want to just set and forget them. You want to be able to use the AWS APIs and infrastructure as code to change these attributes kind of in lockstep with demand. So as your application evolves and as demand changes, you can alter these configurable attributes. So use automation. So we use CloudWatch and we monitor demand, and then we use AWS APIs to actually push configuration changes to these attributes. Another thing you can do is you can use a concept called resource packing. So resource packing is, for example, let's say you're starting off with a new system and you have 3 relational databases that you need to create. You could provision 3 separate RDS instances, but it might be more cost effective to pack all 3 of those databases into a single RDS instance in the early days, right? Until you have enough usage to really necessitate the cost of additional RDS instances. Now, you have to be careful with resource packing, right? Because you're creating, kind of risk there and performance kind of implications, but it's all about that balance, right? Picking the cost-effective resource. Now, when you're making these configuration changes, or you're doing unpacking, right? Like taking your, one of those databases that you've co-located in RDS instance and moving it to a separate one, there's cost, right? There's a system impact to unwinding those things. So when you make a configuration change, it might necessitate, say, a reboot of the RDS instance, for example. Or if you're going to be moving a database, you might have some downtime while that database is moving from one RDS instance to another. So you have to consider these. That's another best practice really under cost-effective resources under appropriate provisioning. So just consider that system impact. Okay, next up, let's talk about right sizing. So AWS defines right sizing as, quote, using the lowest cost resource that still meets the technical specifications of a specific workload. So in order to do that, in order to pick the right resource, the lowest cost resource that meets your demands, first thing you have to do is track what the demands are, right? And AWS recommends that you pick metrics that reflect the end user's experience, right? And that means that you don't just want to pick like averages, for example. You might want to pick, the 99th percentile, or might want to pick maximums. You want to track metrics that reflect that end user experience, so that when you are right sizing, you're not right sizing yourself out of a good experience and into a bad one. So the second thing you need to do is actually evaluate those metrics on the right evaluation window, right? So let's say, one of the metrics you're tracking is sort of CPU utilization on an EC2 instance. If you're only tracking that over the course of a day, you might miss, spikes that happen over the course of a week. Or if you're only tracking it over the course of a month or a week, you might miss something that happens over the course of a month, right? Maybe there's a month-end kind of activity that happens on your application that's going to cause that metric to skew out, and then you won't have right-sized. So AWS essentially remembers that you look at that evaluation window and snapshot across multiple evaluation windows, right? So, and constantly reevaluate. The last kind of benefit or best practice in this section about right sizing is really to balance modification cost against right sizing. So if you're adjusting too frequently, you might actually find yourself causing system-wide issues, right? So it's better to have a slightly more patient approach, right? It's tempting to go and say, oh, I can do this all in real time, right? So as user spikes happen, I can scale things up, but there's a cost to doing that, right? As you're scaling up, you have to maybe provision new resources, right? As you're, expanding the size of an EC2 instance, for example, that has an impact on their system. And so you have to consider that, right? It's better to do it in a little bit more measured kind of step function type approach. And then when demand trails off, instead of immediately kind of scaling down or right sizing back down again, it might be better just to leave that additional capacity there for, some slight delay to ensure that you're not, just in a small trough, right? So it's really about understanding that modification cost and baking that in as you're smoothing out your right sizing. Okay. So this slide is about purchasing options for EC2 instances. And this is a very, very deep and complicated topic, right? So we're going to touch on it today. This right here could be a full webinar. This is all about how to acquire instances from EC2 instances, because there's 3 different purchasing options. Let's go through each and talk about best practices, but know that this is a deep topic that could kind of justify its own webinar. So you're probably mostly aware of this, but I'll give you a little bit of insight into AWS's best practices. The 3 ways that you can acquire an EC2 instance are on-demand, spot, and reserved. So on-demand instances are, kind of the default. This is you pay by the hour for virtual machines as you spin them up. So you spin up an EC2 instance, you start paying. When you shut it off, you stop paying. There's no upfront cost, there's no commitment, there's no contract, right? These also have the highest per hour costs, right? So on-demand instances are really intended for spiky workloads, unpredictable workloads, dev test environments, things that you can readily spin down when you don't need them. So one of the most common kind of mistakes that we see when we go in and engage with a customer to do some cost optimization is that they're overusing on-demand instances. In fact, a lot of organizations are only using on-demand instances, in spite of the fact that they have instances that may run for, days, weeks, months, years, right? So the second is spot instances. Spot instances are a little bit challenging to understand at first, but essentially they work on an auction-like system where you place a bid. You say, I'm interested in an instance of these particular sizes and these particular regions, and you can even say, I need them for a minimum amount of time. You can do them in fleets, so you can say I require a certain number of them. And then when you place your bid, AWS will kind of monitor the current, unused capacity in their infrastructure. And if there's some unused capacity that they're willing to sell you at that price, you'll instantly have those instances provisioned and spun up. You'll get a notification, and there they are. Those instances then can wake up, they can configure themselves, and they can start doing work. The tricky bit is that at any time, AWS can send you a termination notice. They can say, hey, that price is no longer good. You have 2 minutes to clean up, and then we're going to terminate and reclaim that instance. So your instance at that point needs to do save state, right? Maybe snapshot its current work out to an EBS volume or out to S3, save it to Dynamo, wherever it happens to be, and kind of clean up so that it can cleanly exit. Now, you can get up to a 90% discount over on-demand pricing using spot instances. So they're a really important tool in your tool belt. And you can save money by being flexible. So a common mistake people use when they are using spot instances is that they won't be flexible on the region that they're in, or they won't be flexible on the types of instances, sizes, and classes that they're willing to take, right? Be more flexible and you'll have more success bidding in the spot market. The second best practice really here is continuity, right? We talked about that kind of 2-minute notification. Your workload really has to be spot aware. It needs to understand and be aware of the fact it could be terminated at any time and it only has 2 minutes to clean up after itself. Another little trick here that a lot of people don't know is if you have a spot instances that has attached EBS volumes, including the root volume, you can actually snapshot those EBS volumes, and you can set your spot instances to pause as well. So you can say, instead of terminating, pause, and then when the price falls back below my threshold, unpause it so that that spot instance can then resume work right where it left off. So I highly recommend leveraging EBS when you're using spot instances. It's a really good trick. Okay, that brings us to the last option, reserved instances. And actually, you know what? Let's step back one moment. I forgot to mention a little bit about what use cases spot instances are really good for. So I recommend them for batch processing, image video processing, financial analysis, anything that's non-time critical. So if you have kind of an end of month reporting kind of operation you have to do, you could start bidding on that, and in a 5-day period, at some point, know that your spot fleet will get spun up at a very low cost and you can do your processing and snapshot out. So batch video processing, like I said, image and video processing. So those are really good use cases for spot. Okay, now to reserved instances. Reserved instances are probably the best tool in your tool belt for cost optimization on AWS. A reserved instance is an instance that you commit to, right? You're saying, I will pay for this instance over a particular period of time. And you can either say 1 year or you can say 3 years. The longer the commit, the greater your discount. And then there are different types of reserved instances underneath that. So there's a reserved instance in which you pay nothing upfront. That's called a no upfront reserved instance, or a NURI for short. That's kind of a colloquialism. So, and you get the smallest discount when you're not giving them any money, right, upfront. You're just paying over the course of the year on a monthly basis. A partial upfront reserved instance, or a PURI, or PURI, depending on who you ask, you pay a little bit upfront against the kind of life of that instance, and that gives you a much greater discount over the no upfront reserved instance. The third option is an all upfront reserved instance. That's when you pay the entire value of that instance over that 1 or 3 year period upfront, and that gives you the maximum value. Now, customers that we talk to are often pretty resistant to reserved instances because of risk. They're nervous. And I completely understand that. And I think Amazon has done a good job of providing you with different options under that reserved instance kind of model, purchasing model, to kind of mitigate that risk a little bit with no upfront reserved instances or partial upfront. But the other important thing to remember is that there's a whole marketplace for reserved instances. So if you do buy a reservation or an instance reservation, you can resell that after the fact. So if you later determine that you want to get out of that kind of commitment, you can do so. You can sell it to somebody else. The other thing to note is that there are different types of reserved instances around standard and convertible. So a standard reserved instance is essentially saying, I commit to this family size and availability zone, whereas convertible, you have a little bit more freedom. You can convert to different families, updated pricing, different instance sizes, and so on. So this is a very nuanced topic between on-demand, spot, and reserved instances, and the many different ways that you can kind of bid on spot and handle reserved instances. It's a deep topic, but Best tool in your tool belt. If you are nervous about this, Reliam has a ton of experience helping customers with this. People will come to us. We do cost optimization services, cloud optimization services all the time, and it usually happens at almost no cost to the end customer because we save so much money for them. We can go through and do the assessments and help you figure out what to do, mitigate your risk, and so on. So that is a little bit about purchasing options. Now, this is a classic diagram or graph that shows a little bit about how you can think about the different purchasing options. So this is a common, say, usage pattern for a lot of different applications, right? So, at certain spikes during the day, you'll have a high amount of traffic. At other times, you'll have low traffic. And the way to think about this is your baseline traffic, that kind of guaranteed traffic, that's perfect for handling with a reserved instance, right? Or multiple reserved instances. You create those handle your steady state baseline load, right? And then as you have spikes, you can fill in the gaps with on-demand and with spot instances. If you have, kind of reporting and kind of batch processing or asynchronous operations, you can kind of kick out to spot instances that can save you even more money. So this is a way to think about, using those different purchasing options. So let's take a quick breather, have a question. So I'm curious if your organization actually uses the different purchasing options for EC2 instances, or if you're just using on-demand. As I mentioned, we spend a lot of time engaging with customers on kind of cloud optimization, cost optimization as a service, and we find a lot of on-demand instances, right? Or we'll find, kind of a lot of no upfront reserved instances as well. So some money left on the table there. Okay, seeing some answers roll in. Thank you all for being engaged and for giving us some good responses. Okay, let's see here what we got. Ooh, wow. No, 41% are not currently using any of the different purchasing options. And about half of you are using on-demand and reserved. Very, very few people are using spot instances. And that's extremely common, right? In spite of the fact that they're exceedingly useful, you do have to make your applications aware of spot to really make use of them. And that's a big ask for a lot of companies. So again, that's another thing that Reliam helps our customers with all the time. So I totally understand it's a big challenge, but that's interesting. A lot of opportunity in the audience for optimization. All right, let's keep going here. Doing pretty well on time. The next kind of consideration under cost-effective resourcing is geographic selection. So a lot of you probably have applications that have a global reach. You may have customers in Europe or Africa, maybe in Asia Pacific, or even just across the kind of United States, right? AWS provides regions and availability zones kind of spread all over the world to kind of help you have your infrastructure close to the customer and also to comply with kind of data sovereignty and things like that. But it's important to note that these regions operate within kind of the locale that they are under those conditions, right? So power may be more expensive in one region over another, or cooling, right? Because one region may be an extremely hot place, right? So pricing varies pretty widely between regions. And as you're going through and balancing, okay, I have a global reach, but maybe I don't necessarily need to have, my full infrastructure in this most expensive region in the world. You can be a little bit more cost optimized, a little bit more cost effective. And AWS has a tool called the Simple Monthly Calculator. It is simple, but it does give you the ability to actually compare and contrast what running kind of specific workloads would look like in different regions. So you can kind of make educated decisions. So that's really geographic selection. So the next area is managed services. So we talked about this as a design principle, and now we're really talking about this resource selection, right? So instead of spinning up an EC2 instance, installing MySQL on it, spinning up a second one, installing a MySQL slave on that, and then setting up that master slave and managing it, that's a lot of work. You could adopt RDS, right? Saving you a lot of management overhead, EMR, DynamoDB. There's a lot of application level services that AWS has really been working on over the last maybe 5 or 6 years, things like Lambda and SQS, Athena, services that are completely serverless, right? And completely managed, application level even. And their benefits, as we talked about, no servers to maintain, no software licensing to manage, and you benefit from AWS's at-scale operation. And as we talked about, Reliam can take away all the other stuff, right? So if you have a whole bunch of servers, a fleet of servers that you're having to manage, let us take care of it for you. We've got a lot of automation we built to make it, high confidence, super easy to do. So that is a little bit about managed services. So now we move on to the next focus area, which is about matching supply with demand. So what do we mean by supply and demand? Well, supply is your infrastructure that represents, your EC2 instances and your RDS instances, EMR, whatever you're happening to use, the instances that you provisioned, the resources you provisioned within AWS. Demand is your usage, right? So your customer, your end user coming in and actually utilizing your application. And this focus area is all about aligning your spend with the demand of your application and doing it in a cost-effective way. And AWS outlines kind of 3 different approaches. I think you should actually use all 3 of these approaches as appropriate for any given workload. And all 3 of these approaches are really based upon automation and metrics and really reducing cost and eliminating waste from over-provisioning. So let's talk about the first one, which is demand-based scaling. And this is the most commonly thought of approach, right, to matching supply and demand. And it's essentially designing your systems to scale on demand with usage, so almost in near real time. This is also the hardest one to do, right? Because there are things like provisioning time, right? So the way you go about this is you create metrics in CloudWatch to drive scaling events. So things like CPU utilization, the latency for requests in your Elastic load balancers, et cetera. And then you create auto scaling to scale up and down in response to those metrics. The problem is there is provisioning time consideration here, right? So it's not instant. When you create, when you have a CPU spike, right, that you're tracking in CloudWatch, and that indicates that you're having a massive spike in traffic, it isn't just instances are automatically there, right? You have to spin them up and provision them in EC2. That can take a minute or 2, even longer. Those instances, once they come up, they may have startup tasks to complete, right? Configuration. And when you scale down, it's the same kind of thing, right? There's provisioning time and deprovisioning time. So you have to really consider that carefully, and that means you have to be slightly ahead, so a little bit predictive in forecasting. And that's a little bit of a sticky, complicated thing to do. So, definitely expect the unexpected and understand that demand can be unpredictable. And that means try not to have a perfectly smooth curve, right? You don't want your supply and demand locked so tightly that if the demand swings heavily, you're out of whack, right? One little kind of quick tip that I always give people is if you are using on-demand scaling, you want to make that provisioning time as small as possible. And that means you need to do things like pre-baking an AMI, right? An Amazon Machine Image. Pre-configured, no startup task to do. It starts and it runs. You lose some configurability there, but you can actually generate those through automation, through your CI/CD pipelines to get a lot of the same kind of capabilities. But this will really reduce that auto scaling kind of provisioning time lag. So that's demand-based scaling. The next is buffer-based scaling. So this is actually one of my personal favorite techniques. There's a lot of architecture or a lot of workloads out there that lend themselves to a kind of producer-consumer architecture or a kind of publish-subscribe architecture. And AWS provides a couple of different services that will help you with this. So if you have, for example, operations that can be performed asynchronously, right? So someone will ask for something to be done. Maybe there's video processing or image processing, or there's batch uploads of data that need to be processed. You can use a producer-consumer architecture where requests for work are published into some buffer, right, and held in that buffer. And then a pool of workers, of consumers, can then pull on demand off of that buffer. And the nice thing about this is you've separated, decoupled kind of the scaling of your consumer from the producer, right? So as demand goes up, your buffer can just handle it, right? It can queue up work. It may cause delays as you scale up your workers to consume more of those messages, but nothing is breaking, right? You're getting a nice, smoother curve for handling the scale operations. And there's 2 services that you can really use in AWS for that kind of buffering. The first one is Amazon SQS, or Simple Queue Service. And SQS is exactly what it sounds like. It's a queuing service. You get a kind of a queue as a service. So you can create a queue and then you can push messages onto that queue, and messages are then guaranteed to be delivered at least once, right, off the other end of the queue. Now, I said at least once because by default, there's no guarantee that you won't get a single message delivered more than once, right? But it is durable. You can be guaranteed that it will be delivered at least once. In order to save money with SQS, one of the best practices is to publish messages in batches, because each publish actually has a cost associated with it. So if you publish, a queue or a batch of work together at once, you can reduce your cost on SQS. The second thing you can do is you can use long polling to kind of retrieve messages as they arrive. That's another really great best practice for reducing your cost. If you have a use case where messages have to be processed only one time, you can use SQS FIFO queues, first in, first out. That will guarantee that. There is a higher cost to those. So it's actually better if you can design your system to make processing idempotent, which means that a message can be processed more than once with no side effects, right? And that really greatly reduced the impact of duplicate messages. The second system you can use for buffering is Amazon Kinesis. And Kinesis supports more of a publish subscribe model, right? And that means that there's maybe multiple consumers, even maybe of different types, that need to subscribe to messages that come in, right? So an example of this might be a system that has maybe an invoice is coming in for processing. On one side, there's kind of the payment kind of procurement side, and the other side is a notification, right? You could have different systems subscribe to that same message, and they could go off and do their own thing, kind of independent of one another based upon that notification. And the publisher has no idea, kind of what the backend systems are going to do with it. It doesn't care. It just says, hey, notification, this happened. Message into a topic. Subscribers can come in and say, hey, I care about this message. They can consume it and then process. So that's the kind of buffer-based scaling approach, leveraging SQS or Kinesis as kind of a queue or a buffer for work, and then having consumers kind of pull off of that, creating more consumers as necessary. If you want to be extremely cost-effective here, this is a great way to use spot instances, right? So you can even I've seen customers tie their bidding, so the price that they're willing to pay on a fleet of spot instances with the size of their current buffers, right? So as more and more work buffers up, you might be willing to spend a little bit more to clear out buffer out, right? All the way up to the point where you're actually willing to use on-demand instances to kind of handle them. So that's buffering, buffer-based demand, buffer-based scaling. So the last one is time-based. And some of you are lucky enough that you have highly predictable capacity demands based upon time, right? So maybe you're an e-commerce application and you know that you focus on North America. And that means that during business hours from the West Coast to the East Coast, you have high traffic. Overnight, you have low traffic. That's great. You can use the same basic approaches you use with on-demand scaling, right? Using auto-scaling groups, but you can do it based upon scheduled scaling operations. So say scale up in the morning, stay scaled up during the day, scale down at night, right? And you can do this both horizontally and vertically, right? You can resize your instances and you can spin up new instances. The best practices here are really all about reevaluating those usage patterns and asking yourself, what would the impact be of a change in our usage pattern, right? What would happen to our system? Now, the best approach is not to use one of these, it's to use all of these, right? To really think about it clearly and employ all of the tools in your tool belt. So let's talk a little bit about, let's have a question. Does your organization implement an approach for matching supply with demand? And let's see how many of you are using one or more of the approaches we discussed. Right. Thanks for hanging with me here. I know this is a lot of really dense information, but that's part of the fun of the Well-Architected Framework is so much information for you. All right, let's see how we got here. All right, No, the vast majority of you are only using on-demand or no supply-demand kind of approaches at all. In fact, I see 0% of you are using buffer-based scaling, which is my personal favorite. So it's very interesting. Time-based, only 2% of you are lucky enough to do that. So very, very interesting. Thank you for that. Let's now go on to the next slide here. And we're going to talk about the next focus area, which is cost expenditure awareness. So effective decision making, you really need good, clear metrics, right? To understand, where is my money going? Where am I spending most of my money for my infrastructure? Where are my costs, right? So there's 4 different steps that they kind of recommend in the white paper. So the first is to consider your stakeholders, then to gather and aggregate data, attribute costs, and audit resource life cycles. So from a stakeholder perspective, you need to involve the right people to kind of guarantee better outcomes, right? And that means different aspects of the organization, right? So the finance team, financial stakeholders, they really need to be educated on the cloud consumption model, right? What are the different purchasing options? That very in-depth slide we did earlier. And the actual AWS billing reports, which are extremely detailed and kind of sophisticated, complicated to understand. So getting those stakeholders in the room, helping them get educated, and that helps make good decisions. Business unit owners, they need to be empowered to build a good, sustainable, profitable business, right? So understanding what their costs are at a granular level, right? The deeper they can go, the better decisions they can make. And technical leadership should be there, because otherwise hidden costs could be missed, right? And inefficiencies, you could even potentially attribute costs to the wrong product, to the wrong business unit or cost center. So it's important that they're involved. So involving the right people is critical. Next up, you need to gather data. And it's not so much about gathering, it's just being aware of all the places that data can be pulled, right? And AWS provides you with just kind of a wealth of data. So the first is the billing and cost management service, where you can find RI reports for utilization and coverage. You can even define budgets for monthly spend and get alerts. There's a service called Cost Explorer, which you can use to get forecasts. It's very like lightweight forecasting, but it's useful nonetheless. And there's a detailed billing report with resources and tags. And when you enable all of that kind of richness in that report, it's a pretty hefty report. So a lot of people end up having to ingest that data into something like Redshift or into a kind of a BI tool to start analysis. There's also some third-party tools out there that are really excellent. Reliam uses third-party tools frequently when we engage with customers to help surface more insight. But there's a lot of expertise that's necessary. There's some I've mentioned here, Cloud Checker, Cloud Health, and Reliam, for example. We do this on behalf of our customers all the time because it's difficult to do. So what are the methods for cost attribution? There's kind of 2 basic methods. The first is called account structuring, and that is where you actually create multiple AWS accounts and relate them together in a parent-child relationship to kind of segment out resources by however you decide, right? There's no one answer, depends on your organization, but could be by business unit, could be by product, could be by workload or cost center. And then you use consolidated billing to kind of aggregate into a single payer account and get the insight kind of all the way down. So that's one method for cost attribution. The second is tagging. AWS provides pervasive tagging capability throughout all of its services. And that gives you the ability to say tag a particular EC2 instance and say, this is for this product or this business unit or cost center or all of the above, right? And all of that tagging flows down into all of the detailed billing reports that AWS provides you. And that means that you can build very sophisticated reporting. This is one of the most common things that customers come to us and ask our help with, right? We can actually build this into the infrastructure as code templates to ensure that everything is tagged by default, and you get just huge amounts of real-time insight into where your money is going across all different aspects of your organization. So this is a really critical thing. We've helped companies save hundreds of thousands of dollars a month by doing tagging and account structuring. Now, you should probably employ both of these to really be the most effective. Okay, next up is tracking entity lifecycle. So on-demand infrastructure can lead to orphaned or forgotten resources, right? It's really easy for any developer or anybody in the business to just spin up an instance and then forget about it, right? So this is just all about kind of discipline and tracking lifecycle and auditing. And AWS provides some great services, AWS Config, CloudTrail, CloudWatch to kind of help you with auditing your inventory and kind of checking in on yourself on a repeated basis. So that's a important aspect as well. So one more question for you, and then we're getting very near the end. So let's talk about, does your organization have a high degree of expenditure awareness? And that, what I mean by that is, are you using account structuring or tagging, or both, to get an in-depth understanding of where your money's going? Now, based upon the questions and answers so far, my guess is that we're going to have a lot of no here, and maybe some tagging. Account structuring is something that a lot of people don't end up doing, as it turns out. All right, I see answers flowing in. Great, let's see what we got. Yeah, so almost 60% of you are not doing any sort of expenditure awareness or high degree of expenditure awareness. Some of you are doing account structuring. That's actually encouraging. And very few of you are using tagging. So I think there's definitely opportunity here for everyone in attendance. Okay, the last focus area is optimizing over time. And this is one of my favorite topics of conversation, is continuous improvement. I'm a big believer in continuous improvement, and optimization isn't a one-time thing, right? And that continuous improvement to me is sort of the hallmark of an organization that's really fully embraced what cloud can bring, right? That agility, that ability to move quickly and make changes and do so with confidence and optimize. AWS recommends kind of a 4-phase approach. Establishing an official cost optimization function is the first step. You can do that as part of your cloud center of excellence. You can even start a whole new group. You can just have the finance team do it. There's a lot of different ways to do it, but having an official responsibility for that is kind of important. The next is to create some really good, strong goals and metrics to measure against for that function, and then implement tools to actually track progress against those goals and to throw up red flags when things are kind of going sideways. The last real piece of advice here is, because AWS moves so quickly, every year they're announcing dozens of new services and hundreds of new features, price reductions, right? You have to stay evergreen, right? You have to keep up to date as AWS continues to evolve, and that can be a challenge. Again, that's a place where a partner like Reliam can help. It's our job to stay on top of this stuff, and we spend a lot of time helping educate our customers on what's new, bringing them some insights about, hey, this workload you have, you could save a lot of money if you take advantage of this new service. That's kind of a critical value for engaging with a partner. All right. Final question for the day before we go into Q&A is, based upon today's webinar, do you feel that your organization would benefit from well-architected review? So remember, AWS has a program for this. It costs you nothing, and you get $5,000 kind of work done. So it's a pretty great deal. There's a one sheet attached in the handouts if you are interested, and we'll follow up with people afterwards as well. I think most organizations that we've encountered have had a really good outcome. In fact, pretty much all of them. So highly recommend considering well-architected review. So let's see what people think. All right. Yes, over half of you. So that means that I've done a good job today of explaining cost optimization in the well-architected framework. 43% of you aren't sure yet, and only 6% of you are no. So I'll take that as a compliment. That's a good sign. So let's wrap up the webinar and we'll get into some questions. Quick summary of what we talked about here, reviewing the framework itself, how partners can help, and then we went through the design principles and focus areas. So let's go into some Q&A here. I am noticing a fair number of questions. Let's see here. Actually, I'm not seeing the questions, Joshua. They disappeared for me. Here we go. Thank you very much. All right, so got a lot of good questions. Looks like Brian did a good job of answering some of them. First question is, are you seeing an uptake in serverless? Thank you, Wahid, for that question. That is a great question, and yes, we're seeing quite a bit of uptake on serverless, and in fact, we're seeing a lot of Lambda at the edge. That is a very common use case for us. I'm personally doing a lot of serverless development myself. I'm really exploring how to best use it. It's kind of an emerging thing, but we do see that a lot, and it's a great way to save money because you're aligning very, very closely the cost with even a particular function, right? So you can say, this specific feature is costing me this, and if I optimize this Lambda function, I can save money. Any thoughts on moving from DevOps to NoOps? So we as a managed service provider are heavily focused on DevOps. We provide actually DevOps service called Managed DevOps, that we will actually march along with your product teams and your DevOps teams. I'm a big believer in DevOps principles. I think no ops to me is less about no ops, right? No operations, and more about more efficient operations. Taking advantage of managed services, taking advantage of managed service providers like Reliam, and embracing serverless kind of technologies to reduce overhead, right? Let's see. Right sizing is let's see. Right sizing often happens after effect based on production workload. How can right sizing be addressed before the fact in non-production? So you don't know what you don't know, right? So predictive scaling is actually kind of an area of keen interest for a lot of people right now, especially with the excellent machine learning capabilities that Amazon has introduced. Reliam actually has a security service that uses machine learning that does kind of predictive intrusion and anomaly detection. So that type of activity could be applied to scaling, and I think that's a really interesting approach. But realistically, it's implementing a demand-based scaling approach and then learning from metrics as they roll in and rapid, kind of iteration. A lot of thanks. A lot of you're welcome to all of you who said thanks. So someone asked the question about on buffer-based scaling. When you publish a message, is that message leaving or entering the queue or both? That is the message entering the queue. Publishing is putting a message in the queue. Let's see here. And then I have time for one more, and this is about the name Reliam. Where does it come from? History there is it stands for Reliable Internet Application Management. But even newer history lesson is now that we've combined 3 organizations together into one, we're going to be announcing kind of some news on that in the coming months. So, but thank you for asking that question. It's a really good one. All right, we're out of time. I've really enjoyed today. Very good, engaging questions. I think these are the best questions we've had so far. Really appreciate it. And we have one more webinar coming next month on the final pillar of the Well-Architected Framework. Really looking forward to that. We will be in touch via email after this, and I hope some of you decide to act on that instinct to get a well-architected review for your business, because I really believe that it could be a huge benefit to every single one of you. So thank you so much.